You probably open its door a dozen times a day, but do you really understand what's happening inside? Today, we're going to pull back the curtain on the refrigerator and explore the seriously cool science that keeps our food from going bad. I mean, think about it for a second. It really is a paradox, isn't it? This box is plugged into the wall, it hums, it's even warm on the back. And yet, inside, it's cold enough to keep ice cream frozen. How on earth does a warm machine make things cold? That's the mystery we're going to solve right now. But first, before we get into the how, we've got to talk about the why. Why do we even need this thing in the first place? Well, it's because our food is in a constant, relentless race against spoilage. We all start with something perfect, right? A crisp, vibrant, delicious apple. This is the goal, to keep our food just like this, fresh and flavorful for as long as we possibly can. But you know what happens? You leave that apple on the counter for a little too long, and you end up with, well, this. A brown, mushy, unappetizing mess. This is the enemy. But what's actually causing this transformation? The culprit is an invisible enemy, bacteria. These microscopic organisms are literally everywhere. And at room temperature, they're having an absolute party, multiplying like crazy and breaking down our food until it's completely spoiled. So, how do we stop them? With cold, obviously. But the way a refrigerator gets things cold is probably not what you're thinking. It's actually a super clever bit of physics that kind of flips our common sense on its head. Okay, so here's the biggest, most fundamental twist. We tend to think of a fridge as a machine that creates cold, but that's just wrong. Your refrigerator doesn't make cold at all. It's actually a heat-moving machine. It's a heat pump. Seriously, just think about it like this. Your refrigerator is actively grabbing the thermal energy, the heat, from your leftovers and from the air inside, and it's pumping it out into your kitchen. That's why the back of it feels warm. The cold you feel is just the absence of that heat. This process of heat transfer is the key to absolutely everything. So how does this heat-moving magic actually happen? It all works in a continuous loop called the refrigeration cycle. It's basically a 4-step journey for a special fluid called a refrigerant that's designed to be the perfect little heat taxi. This whole cycle is just a clever process of changing that refrigerant's pressure and its state of matter to either absorb or release heat. It all happens in 4 key stages: compression, condensation, expansion, and finally, evaporation. Let's start at the top with compression. It all begins with the compressor. This is the heart of the refrigerator, the engine of the whole system. It takes the refrigerant, which is a gas at this point, and it just squeezes it hard. And just like when you pump up a bicycle tire and the pump gets warm, this process makes that refrigerant gas super hot and super high pressure. Next, that hot, high-pressure gas travels to those coils on the outside of your fridge. You've probably seen them. They're usually on the back. Here, all that heat escapes from the gas and radiates out into your kitchen. And as it loses its heat, the refrigerant cools down and condenses into a liquid. So now we've got this high-pressure liquid. This is where things get really cool. The liquid is forced through a tiny, tiny little opening called an expansion valve. Think of an aerosol can. When you spray it, the stuff inside comes out cold, right? The exact same thing happens here. The pressure drops instantly, and the liquid refrigerant flashes into a very, very cold, misty mix of liquid and gas. And finally, this super cold refrigerant mist flows through a different set of coils, this time inside the fridge. This is where it does its most important job. It acts like a heat sponge, absorbing all the warmth from your food and the air inside. This absorbed heat gives the refrigerant just enough energy to boil and turn back into a gas, ready to head right back to the compressor to start the whole cycle all over again. Okay, so we've successfully moved the heat out. We've made the inside of the box cold. Awesome. But how does this get us back to our mushy apple and those invisible enemies, the bacteria? Well, the effect of that cold temperature is pretty dramatic. As you can see, in the warmth of a room, bacterial activity is just through the roof, which leads to food spoiling really fast. But once you drop the temperature down to what's inside a fridge, poof, the activity plummets. It slows them right down. But here is a really key point. Your refrigerator isn't a death ray for germs. It doesn't actually kill most bacteria. Instead, it just puts them into a state of hibernation. It's basically like hitting a giant pause button on spoilage, which is what gives our food a much, much longer shelf life. So that humble box in your kitchen is actually this amazing piece of engineering, huh? It's a silent superhero in a constant microscopic war. Let's just quickly recap the main things we've learned. Okay, let's put it all together. First and most importantly, your fridge is a heat mover, not a cold creator. It gets this job done using a clever four-step vapor compression cycle. The star of that show is a special fluid called a refrigerant that's designed to absorb and release heat. And the whole point of this entire process, the resulting cold, is to slow down the bacteria that spoil our food.
When you think about it, from a simple science experiment to an appliance in nearly every home on the planet, refrigeration has totally changed how we eat and live. It truly is a box of everyday magic, powered by simple physics. So that begs the question, what piece of everyday technology should we demystify in our next explainer?